Hello friends, in this editorial we are going to discuss our Codechef Starter 140 and our first problem is yoga class. On the occasion of yoga day, the only yoga instructor in chef land, the chef has received numerous queries. Chef has managed to free up n hours, means the chef has total n hours till now. So in this n hours he will take the yoga class. Okay, there is a type 1 session which lasts for 1 hour and charge chef rupees x rupees, and type 2 session which is lasting for 2 hours and it charge the chef for y rupees. Okay, also the x rupees is less than the y rupees, means the chef is getting more money in the type 2 session. Okay, the 2 hour session. So basically we have to print the maximum amount of money the chef can earn in n hours. Okay, now let's try to discuss the example. Okay, so chef has 4 hours. Okay, n equals to 4 and x equals to 5 and y equals to 7. Okay, means chef has total 4 hours and the charge for type 1 session is 5 rupees. Okay, charge for type 1 session is 5 rupees and type 2 session is 7 rupees. Okay, so basically the chef have total what 4 hours. So in these 4 hours he can either take two sessions of 2 hours. Okay, 4 hour means 2 hour plus 2 hour, total 2 type 2 sessions. Okay, total 2 type 2 sessions. As you can see, total 2 type 2 sessions the chef can conduct. Okay, but in 4 hours the chef can also conduct 4 type 1 sessions. Okay, 4 type 1 sessions he can conduct. So basically let's try to see how much he is earning from each session. In type 1 session, 4 multiply 5 means for each hour 5 rupees. So for 4 hours equals to 20 rupees he is earning. And for type 2 session there is only 2 session he can attend. Okay, so 2 into 7 equals to 14 rupees. So basically the chef is earning more from 20 rupees, means the type 1 session. Okay, so we will print 20 rupees, his maximum profit. Okay, so in this example we will check, what we will check, we will check that the each chef is earning more money in the type 1 session than the type 2 session. Okay, so basically it 2, we will do 2 multiply x. Basically what we will do, 2 multiply x, and we will check is this 2 multiply x greater. Okay, is this 2 multiply x greater than the y? Okay, we will check first. Means the profit, means the profit earned in the type 1 session is greater than the profit earned in the type 2 session. We will check. So in this example, the above one, this one, the 2 multiply 5 is greater than the 7, 10 is greater than 7. So that's why what we will print, we will print just n multiply x, means we will just print the type 1 sessions. Okay, just we will check this approach. But what you will do if the difference, means for example let's suppose this, take this example 5 to 6, your n is 5, your x is 2 and your y is 6. But so 2 into x must be greater than 6, as you know, but here 2 into 2 is not greater than, wait a minute, must be greater than y, but 2 into 2 is not greater than 6. 6 is greater than 4 is smaller than what 6 here means our 2 multiply x is smaller than y here, as you can see here. So our that printing n into x approach fails. Okay, it fails. So now what you will do, you will do only one thing, you will do only just one thing. We will check first of all, we have been total given n hours, means 5 hours we have been given, as you are seeing. So in this 5 hours there comes 2 hours of what 2 hours plus 2 hours plus 1 hour. In this 2 hours he can conduct 2 type 2 session and 1 type 1 session. Okay, 2 type 2 sessions and 1 type 1 sessions. So basically our 5 is a odd number. Okay, so we will check how many even numbers are there in this, how many even numbers are there and how many odd numbers are there. Means what, even plus 1 equals to what, odd. As you know, it's a basic maths. Okay, even plus odd equals to 1. Even means 2 plus 1 equals to 3. 3 plus 4 plus 1 equals to 5. Okay, just a simple thing. So in 5 what we will check, we will do 5 by 2. 5 by 2 is equals to what, 2. We can attend 2 type 2 sessions. Yes, in this 5 by 2 we can attend 2 type 2 sessions. Okay, also we will do 5 mod 2. 5 mod 2 equals to what, 1. 1 is remaining. In this we can attend 1 type 1 session. Okay, so 2 type 2 sessions means 2 into y and 1 type 1 session means 1 into x. Okay, just a simple thing. So 2 into 6 plus 1 into 2 equals to 14. Okay, let's take some another example. For example, let's suppose you can take 10. Let's suppose you can take 10. Our n equals to 10. Our x equals to what, 3, and our y equals to what, 7. Let's suppose our y equals to 6. So in this case what you will do, okay, so in this case you will first check our 2 into x is greater than y. Okay, but our 6 is equal to 6, so this approach fails. So what we will do, we will do n by 2 and n modulo 2. Okay, n by 2 equals to what, 10 by 2 equals to 5. Means we can attend to 5 type 2 sessions. Okay, and n modulo 2 is basically what, equal to 0. Okay, as 10 is our even number. Okay, is that clear? As 10 is our even number. So so our 5 into x plus 0 into y. Okay, so basically our x is what, as you can see our x is 3 and y is 6. So 5 into 3 plus 6 into 0. So our profit is basically of 15 rupees. Okay, now let's try to code for this question. Yes, as you can see here, I have checked first I have checked that is 2 into x greater than y. As you can see here, is 2 into x greater than y, and then we will print n into x. Okay, also then I have checked the second approach, the n by 2 multiply n mod 2, this one. Okay, just a simple question and nothing else. Okay, so now let's move on to our next question. Our next question is basically what make permutation. Yes, our next question is make permutation. Okay, basically what is the question says, let's discuss. Shape has been given an array A. Okay, our shape has been given an array A of size n, means our an array A, also its size is n, as you can see. Then so he wants to make a permutation using this array. Okay, so find whether there exists an array B consisting of n non-negative integers, means the array is fully positive, such that the array C constructed as Ci equals to Ai plus Bi equals to permutation, means we have to find Ci, we have to just find Bi and add it to Ai to find Ci. Okay, so our Bi is basically a array, means 1 2 3 4, or 0 1 0 0, basically in the range of 1 to n. It our B is array in range 1 to n. When it add to Ai, it gives a permutation Ci. Okay, whenever it is added to Ai, it gives the permutation Ci. Okay, so basically what, basically let's try to understand it with the help of an example. Okay, we have to print s for if it is a permutation or no, else if it is not a permutation. Let's discuss by with the help of an example. Okay, yes, so we have been given an array 4 1 3 2 1. Okay, as we can see that the array is not sorted. Okay, so let's sort the array one time. So it will be 1 1 2 3 4. Okay, now it's looking better. Okay, now it's looking better, the sorted array. So now we will perform our work on the sorted array. A permutation is basically what, in the range of it must be 1 2 3 4 5, all numbers different, and in a permutation is basically numbers different and in range of 1 to n. Okay, so basically the array is of length what, 5, and all elements are in the range of 5. As you can see here, all elements are in the range of 5. Okay, the maximum element must be equal to the length of the array. So the basic permutation for this question can be 1 2 3 4 5. Our array is 1 1 2 3 4, and we have to add bi, so that the permutation will be 1 2 3 4 and 5. So basically what we can do here, what we can do, okay, to make this array equal to 1 2 3 4 5, what we can do here, we will just go on adding the numbers. Okay, we will just go on adding the numbers to make it 1 2 3 4 5. Basically we can add just 0 1 1 1 1. Okay, if you add 0 1 1 1 to 1 1 2 3 4, it will be 1 2 3 4 5. Means 1 plus 0 equals to what? 1. So basically we must add 1 to 0, 1 plus 0 which gives us 1, 1 plus 1 which gives us what? 2, 1 plus sorry, 2 plus 1 which gives us 3, then 3 plus 1 which gives us 4, and then 4 plus 1 which gives us 5. So this will be our main bi, which is used to form our ci. Okay, so basically this was the example, and as you can see we are able to solve the permutation. But let's discuss the exceptional case. Let's discuss the exceptional case. Our exceptional case is what? The answer question means the which is the array which is not able to form the permutation. So let's discuss this also. 2 4 3 4 2. As I told you, the permutation must be in the range of 1 to n. Okay, as I told you. So basically what you will do now, so basically we know our first of all what we will do, we will sort the array. It will be after sorting it will be 2 2 3 4 4. This is our new array, as you can see. Now we know we have to add bi to it to bring a permutation ci. You know that our array is of length 5. The length of our array is what? 5. So our ci is basically 1 2 3 4 5. This is the best permutation, you can see here. Okay, but now let's see. The length of the array is 5, and you have to add bi to it. Means in 2 2 3 4 4 you have to add the bi, so that it will be 1 2 3 4 5. 2 2 3 4 5 you have to add bi, so that it will give 1 2 3 4 5. But there comes the exception, this one. We cannot add a number to bi, okay, whose output is greater than the number itself. Means what you will add to 2 to give 1, we have to subtract 1 from 2. But our array will be what? Minus 1 0 0 0 0. Okay, this will be our array. But as you can see, the in the problem, in the left side, you can see the B consisting of non-negative integers. You can see the question itself, it must be non-negative, so our this array is fully wrong. Okay, so here as our 2 is greater than 1, as our 2 is greater than 1 and we cannot add a positive integer. If you add 0 to 2, it will be what? 2. This cannot give us. 2 to 1, it will be 3. This cannot be a. Okay, so this array is invalid and the output is no. Okay, the simple thing, and nothing more logic in it, just a simple thing. Let's discuss another exceptional case. Our array is 1 1 1 1 6 6. As you can see that the array is sorted only. So after using the sorting function, it will be the same as 1116 only. So basically, what is the size of the array? Let's see the size of the array. The size of the array is basically 6. As you can see, the size of the array is basically 6. Okay, now we will check. We will check for each I. We have to add bi to it so that our ci will be 1 2 3 4 5 6. Okay, we know our ci. So let's see, one is we as from this array we can see that the elements of ai must be smaller than the elements of ci. Okay, the 1 is smaller than 1 is equals to 1, it's okay, we will add 0 to it. The 1 is smaller than 2, another this also, this also. But there comes another exception case. There comes another exceptional case. Okay, we can see that the c at the 6 is greater than 5 and we cannot add anything to 6. Okay, we cannot add anything to 6 to give 5. What you will add to it to give output 5? Nothing. Okay, so our case fails here. So in this case you have to do just check one thing: if our ai is greater than our I plus 1. Okay, if our ai is greater than our I plus 1, our I is basically, ai is basically what? Let's suppose from our ai is basically a of 0. A of 0 is basically what? 1. 1 is greater than 1 plus 1. Okay, 1 is not greater than 1 plus 1. So basically our error comes here only. Okay, as you can see. So that's why these cases are exceptional, and this is the code output for this question. Basically I have sorted the array here. As you can see, I have sorted the array and taken f equals to 1. This f equals to, I have taken 1 and I have iterating the for loop. I am just iterating the for loop for each I. Okay, I am iterating the for loop for each I. Means for I equals to 1 2 3 4 5 6. Okay, and I am checking the for each number. If I get this is my ci and this is my ai and this is my ai. If I find any number which is greater than the ci, so we will just go to f equals to, we will just do f equals to 0. Okay, and in the last, and if it's, and if we'll not get a any number, we'll just continue. So now at last we are checking if not f. If not f means if our f is equals to 0, we will just print no, or else our f will be 1 only and we will print s. Okay, so this was the question. Let's move on to our next question. Our next question is trick or treat. Okay, basically the question is simple. Okay, the question is very simple and easy. The, as you can see, the difficulty level is 1400, but to that difficulty is very simple. Okay, means in the understanding of question, but what comes in the between is the time complexity. The time complexity affects the code of the question. So let's read the problem statement. Halloween is approaching and you plan to distribute sweets to the children in your house. Okay, visiting your house. So you expect a total m children. So basically m children are there. M children are there, and you have n boxes of candies. N boxes of what? Candies. And same n boxes of what? Chocolates. Same means you have equal number of boxes of candies and equal number of boxes of chocolates, and you have to choose exactly one box of candies and exactly one box of chocolate. Okay, and you will then mix the selected candies and chocolates and distribute the combined sweets equally among the m children such that no sweet is left. So each child should receive same number of sheets, but the type of sweets do not need to be identical. And count the number of ways to choose one box of candy and one box of chocolate to be able to evenly distribute the sweets among the m children. So the question is very simple. You have been given the for example the size of the array 4. You have been given the size of the array as 4. Okay, the number of children visiting your house is 5. Okay, and you have the total number of candies. And chocolates. So basically what will be our array? Our array will be 2, 8, 3, 10. Also will be 5, 12, 15, 13. Okay, so what you have to do, we have to find number of ways so that we can get equal one box of candy and one box of chocolate, and distribute the number of chocolates and candies among the m children, so that no chocolate and candy is left. No chocolate is left means no sweet is left. Mark these words. Okay, so basically what, basically you have to find the, you have to means what you have to do. Wait, let me explain it. Yes, you have been give, huh. So you have to permute means permutate or what you call in your own words, I don't know. You have to permute the each element of the array with the another elements of the another array, means you have to add. Okay, so this is giving 7, 14, 17 and 15, and you have to check is any of the element in the array is divisible by the number of children. So 7 is not divisible, number of children is what, m equals to what, 5. 7 is not divisible by 14. 7, 14 is also not divisible, 17 is not divisible, but 15 is divisible by 5, as 15 mod 5 equals to 0. Okay, so we have got, so now our count is equals to what, 1. Okay, then wait a minute. Yes, then again you have taken the array 2, 8, 3, 2, 8, 3, 10, then 5, 12. Let me separate it. 5, 12, 15 and 13. Okay, so our, as you know, our 2 is completed. Now we will do for 8. 1, 2, 3, 4. Add each element to it. So 8 plus 5 is equals to what? 8 plus 5 is 13. 12 plus 8, 20. 8 plus 15, 23. And 13 plus 8 is 21. As you can see, here, that we are get not, means only 20 is divisible by 5. Okay, as only 20 is divisible by 5 here. Number of children, 5 is what, number of children, keep in mind. So we can distribute 20 chocolates equally among 5 children. If it is divisible, means we can distribute. So our count is now what, 2. Okay, now basically again we will take the array 2, 8, 3, 10, 8, 3, 10, 5, 12, 15, 13. Okay, now we will add 3, 3 to 5, 12, 15 and 13. Okay, now we will add, as you know, our counter is equals to what, 5, means, sorry, our counter is equals to what, counter is equals to 2. Okay, now 3 plus 5 equals to what, 8, then 15, then 18 and then 16. As you can see, our only 15 is divisible by 5. 15 is divisible by 5. Okay, means you can distribute 3 chocolate to each children. Okay, one candy, one chocolate, or one candy, or 2 chocolates or 1 candy, whatever, but you can distribute equally 3 chocolates among 5 children. Okay, so now our count is what, means number of ways is 3. Okay, there comes a last approach, 2, 8, 3, 10, then 5, 12, 15, 13. Now we will add 10 to all numbers. 10 plus 5, 12, 15 and 13. So basically 10 plus 5 is 15, 22, 25 and 23. Wait a minute, let me make it more clear for you. what happened? We have our 15 here, 22, 25 and 23. As you can see that our 15 and 25 is divisible by 5, so our count will be what? Our count will be 5. We have got here two numbers which are divisible by 5, so 3 plus 2 equals to what? 3 plus 2 equals to what? 5. As so our output, so our output for this whole problem is what? 5 ways. As you can see here, we have got our 5 as output. Okay, next another example is what? For example, you have been given 3 is the size of the array and one child. You have to distribute the chocolate among only one child. Okay, so the array is 10 to the, let's suppose the array size is what? 1 2 3 4 5 6 7 8 10 to the power 9, 10 to the power 9, 10 to the power 9. Okay, also 10 to the power 9, 10 to the power 9, 10 to the power 9. The, as you can see, the size of the array is always the same, and you have to distribute the chocolates among only one children. But this, but the elements of the arrays are what? Equal. So what you can do, only just do one thing, just do only one thing, multiply the size of the array with another size. If you see either the number of child is same or the elements of the array is same, just multiply the size of first array with the size of second array. Here the size of first array is what? 3. Also here the size of the second array is what? 3. So 3 multiplied 3 is equals to 9. Just simple thing. Now next example, the size of the array is 1 and the number of children is 100, means you have to distribute chocolate among 100 children. So basically this is the candies and this is the chocolates. So we have only one way, either add these numbers only. Okay, I have only one way only. So 23 plus 76 is what? It's 99. 23 plus 76 is 99. Okay, so basically as you can see that our we have only the combinations. 99 is what? Chocolates plus candies is less than the children. How come we can distribute equally? Okay, 99, we have only 99 sweets. How come we can distribute in between 100 children? Okay, so it's not possible for here, so our output will be what? 0. Okay, now let's try to understand it with the help of code. First of all, I have created an array to count the occurrences of remainders. Okay, I have just created an array to count the occurrences of remainders. Okay, so I am just counting the remainders for each candy, means for A in CA. Basically this one, for example, you have been given like only one child. You have been given the size of the array is what? Basically size of the array is 2 and you have been given one child and the array is 10 10 10 10. Okay, one is M, this is N, this is our, this is basically our candy and this is basically our chocolate. Okay, so the count of candy will be what? Basically our M is equals to what? 1, as you can see. So our count will be what? our count CA will be equals to what? 0. Okay, and same our count CH will be equals to what? 0 here. Okay, because our M equals to 1, so 0 multiply 1 is 0 only. Our count will be only 1 only. Okay, for example, if we have been given, for example, we have been given M equals to 3, so our count CA will be equals to what? 0 0 0. Okay, so this is basically the approach. Okay, now we are checking the remainders, counts A mod M. Okay, for each element in the candies we are checking its remainders, and also for the chocolates. Then what we are doing? We are doing finding the J. We are just finding the J equals to M minus I mod of M. Okay, so this is I plus, it's equivalent to I plus J mod M. Okay, just a simple thing and nothing else. So basically this was the approach. Okay, I think you have understand the code. It's, I know it's pretty difficult. Okay, it's just a pretty difficult and nothing else. This is only for the sake of the time complexity. Okay, I told you at the starting of the video, the time complexity affects the difficulty of the code. Okay, the code was very easy. The code was literally very easy. Let me show you the submission. As you can see here, the code, this was the original code for this question. Okay, and you can see that it was just giving time limit exceeded. So because of that I have to use this approach. I have to just use this approach because of only this only. Okay, so just a simple thing, I am uploading the drive link for each iteration. Okay, in the description, so you can see each and every. And now let's move on to our next question. Okay,